In our previous lecture, we have learnt about unsaturated hydrocarbons. In unsaturated hydrocarbons, we have alkenes and alkynes. Let's revise what are unsaturated hydrocarbons. These hydrocarbons contain carbon-carbon double bonds or carbon-carbon triple bonds. Let me show you these examples. You'll understand better when it is explained with diagrams. So this is carbon-carbon double bond. There is a double bond between two carbon atoms, or carbon-carbon triple bonds. There is a triple bond between two carbon atoms. These compounds are called unsaturated hydrocarbons because they contain carbon and hydrogen only. Because one of the double bonds of an alkene or one or two of the triple bonds of alkynes can be broken to add hydrogen atoms to the carbons. Example, let's see an example. This is CH2 double bond CH2. See, each carbon atom is having 4 bonds, 2 with hydrogen, 2 with another carbon. Similarly, this carbon is having 2 bonds with this carbon atom, and this carbon atom in turn is having 2 bonds with this carbon atom. So it is a double bonded hydrocarbon compound. This is an alkene. Its name is Ethyne. We have learnt it in previous lecture. If one of the double bond breaks, two hydrogen atoms can be added to either of the carbon atoms. Then it becomes CH3 single bond CH3. This is the new hydrogen atom added to each carbon atom. This becomes ethane, which is an alkane and a saturated hydrocarbon. Let's see the example of alkyne. As we know, alkyne has a triple bond between two carbon atoms. So this is ethyne, an alkyne of simplest form. CH triple bond CH. If one of the bond breaks in the triple bond, a hydrogen atom can be added to each of the carbon atom. These are the new hydrogen atoms added. So this becomes CH2 double bond CH2, which is ethene and alkene, because there is a double bond between carbon-carbon atoms. If one of the double bond cleaves and another hydrogen atom is added to each carbon atom, this becomes CH3 single bond CH3, which is ethane and alkane. It is a saturated hydrocarbon. So alkynes are called unsaturated hydrocarbons because one or two of the triple bonds can be broken to add hydrogen atoms to the carbons to become saturated hydrocarbons. So these are alkynes are unsaturated hydrocarbons. Alkynes can be divided into OpenChain alkynes and cyclic alkynes. Now in this lecture we will be learning about OpenChain Alkynes. In our previous lecture we have learnt about unsaturated hydrocarbons. In unsaturated hydrocarbons we have alkenes and alkynes. Let's revise what are unsaturated hydrocarbons. These hydrocarbons contain carbon-carbon double bonds or carbon-carbon triple bonds. Let me show you these examples. You'll understand better when it is explained with the diagrams. So this is carbon-carbon double bond. There is a double bond between two carbon atoms, or carbon-carbon triple bonds. There is a triple bond between two carbon atoms. These compounds are called unsaturated hydrocarbons because they contain carbon and hydrogen only. Because one of the double bonds of an alkene or one or two of the triple bonds of alkynes can be broken to add hydrogen atoms to the carbons. Example. Let's see an example. This is CH2 double bond CH2. See, each carbon atom is having 4 bonds, 2 with hydrogen, 2 with another carbon. Similarly, this carbon is having 2 bonds with this carbon atom, and this carbon atom in turn is having 2 bonds with this carbon atom. So it is a double bonded hydrocarbon compound. This is an alkene. Its name is Ethyne. We have learnt it in previous lecture. If one of the double bond breaks, two hydrogen atoms can be added to either of the carbon atoms. Then it becomes CH3 single bond CH3. This is the new hydrogen atom added to each carbon atom. This becomes ethane, which is an alkane and a saturated hydrocarbon. Let's see the example of alkyne. As we know, alkyne has a triple bond between two carbon atoms. So this is ethyne, an alkyne of simplest form. CH triple bond CH. If one of the bond breaks in the triple bond, a hydrogen atom can be added to each of the carbon atom. These are the new hydrogen atoms added. So this becomes CH2 double bond CH2, which is ethene and alkene, because there is a double bond between carbon-carbon atoms. If one of the double bond cleaves and another hydrogen atom is added to each carbon atom, this becomes CH3 single bond CH3, which is ethane and alkane. It is a saturated hydrocarbon. So alkynes are called unsaturated hydrocarbons because one or two of the triple bonds can be broken to add hydrogen atoms to the carbons to become saturated hydrocarbons. So these are alkynes are unsaturated hydrocarbons. Alkynes can be divided into OpenChain Alkynes and cyclic alkynes. Now in this lecture we will be learning about OpenChain Alkynes. OpenChain Alkynes, they have a straight chain of carbon-carbon atoms with at least one carbon-carbon triple bond. General formula of alkynes is CnH2n-2. For alkenes it was CnH2n. Here CnH2n-2. Simplest alkyne with open chain is Ethyne, C2H2. If we apply this formula here, C is 2, that means N is 2. So C2, double of 2 is 4, minus 2 is 2. So simplest alkyne is Ethyne, C2H2. This can be written like this: HCC, C triple bond C, H. This is Ethyne. Nomenclature of open chain alkynes depend upon the number of carbon atoms they contain. So, if the number of carbon atoms is 2, the root word will be eth, suffix will be "-ine". So, the name of the compound becomes Ethyne and the molecular formula will be C2H2. If the number of carbon atoms is 3, it becomes, root word is prop and suffix is "-ine". So the name is propane, C3H4. If the number of carbon atoms are 4, the root word is but, 4 is but, suffix "-ine" as usual, so it becomes butane, which is C4H6. Similarly, 5 carbon atoms will become pent and ine, pentane, C5H8. 7 carbon atoms, hept plus ine, heptane, C7H12. 8 carbon atoms, oct plus ine, octane, C8H14. 9 carbon atoms, non. 9 stands for non. 9 stands for non. And suffix is "-ine". So the name will be No9. That is C9H16. 10 carbon atoms, dec plus ine will become decyne. So this will be octane, 9 carbon atoms will be No9, 10 carbon atoms will be decyne. He must have noticed that from Ethyne to propane, there is a difference of CH2. C2H2 becomes C3H4. C3H4 to C4H6, there is a difference of CH2. So each subsequent compound will have 1 carbon atom and 2 hydrogen atoms more. This trend will continue indefinitely. So these are the open chain alkynes. Let us see one by one. The first and foremost OpenChain alkyne is 2 carbon atom alkyne, because to have a double bond between 2 carbon atoms we need 2 carbon atoms. So it is called eth plus ine ethyne. Number of carbon atoms 2, root word is eth, and ine is the suffix. So the name is ethyne. C2H2 is the molecular formula. Structure of ethyne can be written as HC double bond, a triple bond C H. This is the structure of ethyne. Condensed structure of ethyne. Condensed is nothing but we'll remove the bond between carbon and hydrogen and attach it to the carbon atom. So it will become CH triple bond CH. There are 2 carbon atoms. There is a triple bond between them. So it is called ethyne. We cannot possibly draw a second structure to this. Okay. The skeletal structure of ethyne will be, draw 3 lines. This end represents CH. This end represents CH. So CH triple bond CH is the skeletal structure of ethyne. Common name of ethyne, a very famous name known to even uneducated people. It is acetylene. It is called acetylene. Physical state of this ethyne is gas. Uses of acetylene or ethyne are best fuel for welding. Welding work is done by mostly acetylene or oxyacetylene, and it is used for cutting metals and for brazing metals. So these are the uses of ethyne or acetylene. Now let's see the second member of this OpenChain alkynes. The second member is 3 carbon atom alkyne. Since there are 3 carbon atoms, it is called propane, because number of carbon atoms 3 represents prop, suffix sign. Name is propane, C3H4, molecular formula. Structure of propane can be written like this. C single bond H, C and C are connected by triple bond. This second C and third C are connected by single bond, and this third carbon atom is having 3 hydrogen atoms attached to it. This is 1 propane or prop1ine. If we shift the triple bond between 2 and 3, this becomes also 1 propane, because when the functional group, that is the triple bond, is between these 2 carbon atoms, we should name the compound in such a way that the triple bond gets the least number. So we cannot count from here and say 1, 2, 3, because the triple bond is here. We have to count from this side. So this is also 1 propane. So propane has only 1 propane. Let's see the condensed form, condensed structure of 1 propane. Condensed is nothing but we remove the bond between hydrogen and carbon. So this is CH triple bond C single bond CH3. This is 1 propane. This is also 1 propane. CH3 single bond C triple bond CH. This is also 1 propane. Okay, let's see the skeletal structure. The skeletal structure of 1 propane is, you draw a V-shaped like lines. This represents first carbon, this represents second carbon, this represents third carbon. Draw two more bonds here. That means we are representing triple bond between first carbon and second carbon. Similarly, here we are representing triple bond between first carbon and second carbon. This is the skeletal structure of 1-propane. Now the common name of 1-propane is methyl acetylene, because we have written in this condensed form CH3 C triple bond CH. So similarly we can write like this: CH3 single bond C triple bond CH. This is methyl group. This CH3 is methyl group. This is acetylene. So this is called methyl acetylene. This is the common name of 1-propane. Physical state: it is a gas. Uses: it is used in the synthesis of phenyl acetylenes. It's used in the synthesis of phenyl acetylenes. So this is about propane, which has only one structure, that is 1-propane. Now let's see the next structure. It is 4 carbon atom alkyne. Since it has 4 carbon atoms, it is called butane, because 4 carbon atoms. The root word is but and suffix is -ine, so the name will be butane. Its molecular formula is C4H6. Let's see the structure of butane. We can draw two types of structure for this one butane. In one butane, the triple bond is between first carbon and second carbon, so it is called 1-butane. Here there will be one hydrogen atom, here there will be 2 hydrogen atoms, 3 hydrogen atoms for the fourth carbon. Similarly, from this side, this carbon atom will be called 1, and this 2, 3 and 4. First carbon and second carbon have a triple bond. First carbon has a hydrogen atom attached to it. The second carbon has no hydrogen atoms attached to them, because it is already having 3 plus 1, 4 carbon bonds. The third carbon has 2 hydrogen atoms attached to it. The fourth carbon has 3 hydrogen atoms attached to it. It is nothing but the reverse of this first structure. So this is also 1-butane, this is also 1-butane. If the triple bond is between second carbon and third carbon atom, it is called 2-butane, because the triple bond starts at second carbon. So butane has two structures, that is 1-butane and 2-butane. Let's see the condensed structures of butane. 1-butane, CH triple bond C, single bond CH2, single bond CH3. This is 1-butane. CH3 single bond C triple bond CH3 is 2-butane. This is also 1-butane, because CH triple bond C single bond CH2, single bond CH3. This is also nothing but reverse of this structure. So this is also 1-butane. So butane has two structures, 1-butane and 2-butane. Let's see the skeletal structures of butane. This is the first butane, 1-butane, because the triple bond is between first carbon and second carbon. This is the second 2-butane, because the triple bond is between second and third carbon atoms. This is also 1-butane because the triple bond is between first carbon and second carbon. So these are the two main structures of butane. Now, common name of butane. What is the common name of butane? 1-butane is called ethyl acetylene. Let's see this. This is the condensed form of 1-butane. There is a triple bond between first carbon and second carbon. This part is called acetylene. The second part, CH2, CH3, is called ethyl part. So it is called ethyl acetylene. This is one common name of butane. Ethyl acetylene. Ethyl acetylene. Okay. 2-butane. Condensed form is CH3 single bond C triple bond CH3. So this part is a methyl part. This is another methyl part. This is acetylene part. So it is named as dimethyl acetylene. 1, 2, dimethyl acetylene. These are the common names of butane. Physical state. It is a colorless gas. Uses of butane. It is used in the synthesis of organic compounds and instrument calibration. So there are mainly two uses for butane: synthesis of organic compounds and instrument calibration. So we have finished with butane. Let's see the next. Next member of the open chain alkynes is 5 carbon atom alkyne. 5 carbon, as you know, will be called pentane because it has number of carbon atoms 5, so it is called pent, and suffix is -ine, so it is called pentane. The molecular formula is C5H10. Structure of pentane: HC triple bond C, single bond CH2, single bond CH2, single bond CH3. This is one pentane. Similarly, when the triple bond is between 2 and 3 carbon atoms, it is called 2-pentane. So it has two structures only, because if we place the triple bond here, this 5th carbon atom will become first carbon atom, so it will become again 1-pentane. Similarly, if we place the triple bond here, this 4th carbon atom becomes second carbon atom, so it will become 2-pentane. So there are only two possible structures: triple bond between first carbon and second carbon, 1-pentane, second carbon and third carbon, 2-pentane. Now let's see the condensed structure of pentane. CH triple bond CH triple bond C, single bond CH2, single bond CH2, single bond CH3. This is 1-pentane. And CH3 single bond C, triple bond C, single bond CH2, single bond CH3 is called 2-pentane. In a condensed form, it can be written like this. Okay, CH3 single bond C triple bond C, single bond C2H5, CH2 CH3 are written combinedly like this. Skeletal structure of pentane. So we know we have only two structures, one pentane and two pentane. One pentane, this is one carbon atom, this is second, third and fourth and fifth carbon atom. Draw a triple line between first carbon and second carbon, it becomes one pentane. Draw a triple bond between second carbon and third carbon, it becomes two pentane. So there are only two structures possible for pentane. Those are one pentane and two pentane. Let's see the common names of pentane. So we can draw the condensed structure. CH, triple bond C, single bond C2H7. This portion is acetylene. CH, triple bond C is acetylene. C3H7 is propyl. So it is called propyl acetylene. One pentane can be written as propyl acetylene because after acetylene group we have 3 C's. 3 C's is propyl. So it will have how many hydrogen atoms? 7 hydrogen atoms. So this is propyl part. Similarly, 2 pentane can be written like this. CH3, single bond, C triple bond C, single bond C2H5. C2H5 is nothing but CH2, CH3. This is ethyl part. It is an ethyl part. By knowing it, seeing it only, we can recognize it as ethyl. This is methyl. So it is called ethyl methyl acetylene. Ethyl methyl acetylene. Why can't we call it methyl ethyl acetylene? We cannot call it because as per IUPAC nomenclature, alphabetical order should be followed for substituted groups. E comes first, then M. So it is ethyl methyl acetylene. Physical state of pentane is it is a colorless liquid. Up to butane we have seen as gas. Now this is liquid. Uses. Pentane is used in the synthesis of various chemical compounds. So we have learned 5-membered acetylene, 5-membered alkyne. So that is acetylene. Now let's see what is 6-membered alkyne. 6 carbon atom alkyne is called hexane because since the number of carbon atoms are 6, it is called hex and suffix is ine, so the name is hexane and molecular formula is C6H10. Let's see the structure of hexane. H, C, triple bond C, single bond CH2, single bond CH2, single bond CH2, single bond CH3. This is one hexane because the triple bond is starting at carbon 1. Similarly, if the triple bond starts at carbon 2, it is called 2-hexane. Similarly, if the triple bond starts at carbon number 3, it is called 3-hexane. So if we write triple bond here, it becomes 1-hexane again. If we draw triple bond here, it becomes 2-hexane. So we cannot write any more structures. So there are 3 structures for hexane. 1-hexane, 2-hexane and 3-hexane. Okay, let's see the condensed structures of hexane. 1-hexane will be like this. CH triple bond C, single bond CH2, single bond CH2, single bond CH2, single bond CH3. This is one hexane. 2 hexane, CH3 single bond C, triple bond C, single bond CH2, single bond CH2, single bond CH3. This is 2 hexane because the triple bond is starting at second carbon. Similarly, if the triple bond starts at carbon number 3, it is called 3 hexane. So these are the three structures of hexane. Let us see their skeletal structures. So let's draw the skeletal structures. You draw a line like this, bring it down, go up, bring down. So you have 6. 1, 2, 3, 4, 5, 6. These numbers represent carbon atoms. So there is a first draw 2 more bonds here. It becomes triple bond. So the triple bond is between first carbon and second carbon. It is 1 hexane. Similarly, if you draw the triple bond between 2 and 3 carbon atoms, it becomes 2 hexane. If the triple bond is drawn between 3 and 4 carbon atoms, it becomes 3 hexane. These are the skeletal structures. Sometimes in the books they will be written like that. So you should know the skeletal structures. Common names of hexane. What are the common names of hexane? The common names of hexane are N-butyl acetylene. N-butyl acetylene. N-butyl acetylene is nothing but there is a triple bond between first carbon and second carbon. So this is acetylene part. The remaining carbon atoms are 4. So it is butyl part. So it is called N-butyl acetylene. N-butyl means it is not having any branches. This is the name of 1 hexane. Let's see the name of 2 hexane. The triple bond is between second and third carbon atoms. There is a methyl group before it. And the remaining 3 carbon atoms, they form propyl group. So it is methyl propyl acetylene. Methyl propyl acetylene, because alphabetical order we should go. M comes before P. So it is methyl propyl acetylene. These are the common names. Another name for this can be for 3 hexane. This is for 3 hexane. 3 hexane, the triple bond is between third and fourth carbon atoms. So we can divide it into 3 parts. One is acetylene part. Acetylene part is between third carbon and fourth carbon. This is acetylene part. On this side we have 2 carbon atoms. This side we have 2 carbon atoms. So this is one ethyl part. This is another ethyl part. So you get diethyl acetylene. I'll write here. It is one ethyl part and this is another ethyl part. So it becomes diethyl acetylene. Diethyl acetylene or hexane is a colorless liquid. It is a colorless liquid. Now let's go to the next member of the OpenChain alkynes. The next member of the OpenChain carbon alkyne is 7 carbon atom alkyne, that is heptane. So here the number of carbon atoms are 7. So The root word is hept and the suffix is "-ine". So the name is heptane. Molecular formula is C7H12. Structure of heptane: CH, triple bond C, single bond C, single bond C, CH2, single bond 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 CH3. Altogether there are 7 carbon atoms. We have to write the structure so that each carbon atom gets 4 bonds. So this is one heptane. Similarly, we can draw 2 heptane by drawing a triple bond between second and third carbon atoms and then drawing 4 bonds to each carbon atom. This carbon atom has 4 bonds because 3 with hydrogen, 1 with carbon. This carbon has a single bond with this carbon atom, first carbon atom, and triple bond with third carbon atom. So it has 4 bonds. Third carbon atom has 3 bonds with this second carbon atom and 1 single bond with fourth carbon atom. So it is also having 4 carbon atoms. Similarly, we see all these are having 4 bonds. So this is 2 heptane. Let us see 3 heptane. 3 heptane has triple bond between C3 and C4. So that is why it is called 3 heptane. Let's see the condensed structures. Condensed is nothing but we bring hydrogen and carbon nearer, that's all. CH triple bond, single bond CH2, single bond CH2, single bond CH2, single bond CH2, triple bond CH2. This is one heptane. Similarly, 2 heptane. The triple bond should be between second and third carbon. 3 heptane. The triple bond should be between third and fourth carbon atoms. So this is written as CH3, single bond CH2, single bond C, triple bond C, single bond CH2, single bond CH2, single bond CH3. This is 3 heptane. So heptane has 3 structures. 1 heptane, 2 heptane, 3 heptane. Okay. Now the skeletal structures. You draw a zigzag line like this. So name them 1, 2, 3, 4, 5, 6, 7. They represent 5 carbon atoms. So for the first, between the first carbon and second carbon, you draw 2 more lines. So that becomes a triple bond. This is 1 heptane. In the next structure, if you draw 2 more bonds between 2 and 3, it becomes 2 heptane. For the next figure, if you draw 2 more bonds or lines between 3 and 4, it becomes 3 heptane. This is the skeletal structures of heptane, physical state of heptane. Heptane is also colorless liquid. Uses of heptane. It is used in the synthesis of complex acetylenic molecules. So it is used in the synthesis of complex acetylene molecules which are used in perfumes, pharmaceutical preparations and agrochemicals. So it is used to prepare complex acetylenic molecules used in perfumes, agrochemicals and pharmaceutical products. Now let us see the next member of the OpenChain Alkynes. The next member of the OpenChain alkynes is 8-membered alkyne. 8-membered alkyne is called octane, because we know 8 carbons means root word will be oct, suffix will be ine, name will be octane. Molecular formula will be C8H14. Let's see the structures of heptane. Octane. 1 octane. 1 octane is nothing but triple bond between first carbon and second carbon, and there are 8 carbon atoms with 4 bonds each. So each carbon should have 4 bonds. The first carbon is having 1 bond with hydrogen and 3 bonds with carbon. The second carbon is having 3 bonds with first carbon and 1 bond with the third carbon. The third carbon is having 2 bonds with adjacent carbon atoms and 2 with hydrogen atoms. So this has 4 bonds. Similarly, all other carbon atoms are also having 4 bonds each. This is the structure of 1 octane or oct1ine. Let's see its condensed structure. Condensed structure is nothing but CH triple bond, C single bond CH2, 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 single bond CH2. This is the structure of 1 octane. This is the skeletal structure. You draw zigzag lines like this up to 8. So they represent 8 carbon atoms. Draw 2 more lines between 1 and 2. It becomes a triple bond. So this becomes 1 octane. Let's see 2 octane. The triple bond will be between second and third carbon atoms. The condensed structure will be similar. CH3, see here we have seen CH3. This is CH3. C triple bond C. Single bond CH2, single bond CH2, single bond CH2, single bond CH2, single bond CH3. This is 2 octane because the triple bond is between 3 and 4, 2 and 3 carbon atoms. The skeletal structure, we draw 8 lines again and draw 2 extra lines between second and third carbon atom. That becomes 2 octane. Let's see how many more structures octane has. This is 3 octane or oct3ine. Let's see its structure. The triple bond will be between third and fourth carbon atoms. So it is called 3 octane. Condensed structure will be like this. By now you should be aware of it. CH3, CH2, C triple bond C, CH2, 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 CH3. The skeletal structure will be like this. So you draw 2 more bonds between 3 and 4. That becomes 3 octane. Okay. Let's see 4th octane if it is possible. So let's see 1, 2, 3, 4, 5, 6, 7, 8 carbon atoms. Let's draw triple bond between 4 and 5 carbon atoms. So this becomes 4 octane. So the condensed structure will be same like the others. It will start with CH3, end with CH3. There is a triple bond between 4th and 5th carbon atoms. Okay. The skeletal structure will be like this. 8 carbon atoms. We will draw 2 extra lines between 4 and 5. So that becomes 4 octane. Now you may be thinking we can draw a triple bond here. If we draw a triple bond here, this becomes 1 octane. If we draw a triple bond here, it becomes 2 octane. Already we have 2 octane. If we draw a triple bond here, it becomes 3 octane. We already have 3 octane. This is anyway 4th octane. So we have only 1, 2, 3, 4 structures for octane. Its physical state is also liquid. I forgot to write. The physical state is of octane is gas. So up to the first 3 members, it was liquid in gas. This is liquid, sorry. It is a liquid. Uses of octane. Octane is used in organic reactions. It has many uses. We can see from here. Halogenation, hydration, hydrohalogenation, oxidative cleavage, nitrile formation, polymerization, hydrohalogenation, and substitution reactions. So this octane is having a number of uses. It is used for halogenation, hydration, hydrohalogenation, oxidative cleavage, nitrile formation, polymerization, and hydrohalogenation and substitution reactions. Now let's see the next number of OpenChain Alkynes. The next member is 9 carbon atom alkyne. Since it is having 9 carbon atoms, it is called No9. 9 carbon atoms means known, suffix is "-ine", name is No9. Formula is C9H16. So this is No9. So let us start with the structures. One No9 structure. The triple bond will be between first carbon and second carbon. There will be 9 carbon atoms, and each carbon atom will have 4 bonds. So if we satisfy that, we will get the structure of No9 very easily. One No9. This is the condensed structure. CH triple bond C, single bond CH2, 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 single bond CH3. This is 109. Let us see the skeletal structure. Draw zigzag lines like this up to 9 and draw 2 more lines between 1 and 2. So this becomes 109. Let us see 209. 209 structure. The triple bond will be between second and third carbon atoms. So it is called 209. Condensed structure. In the same way we write CH3, single bond C, triple bond C, single bond CH2, 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 single bond CH3. This is 209 skeletal structure. Draw zigzag lines like this and add 2 more lines between 2 and 3 carbon atoms because it is 209. Let us see now 309. 309 is nothing but the triple bond will be between third and fourth carbon atoms. All the other carbon atoms will have hydrogens and each carbon atom should have 4 single bonds, okay, except 3 and 4 which have triple bond between them. The condensed structure of 3No9: CH3 single bond, CH2 single bond, CH3 carbon, single bond CH2, single bond CH2, single bond CH2, single bond CH2, single bond CH3. There are altogether 9 carbon atoms. So it is a No9. Since the triple bond is between third carbon and fourth carbon, it is called 3No9. So skeletal structure we can draw like this. Add 2 more lines between 3 and 4. So this becomes 3No9. Now next structure of No9 is 4No9. The triple bond will be between 4th and 5th carbon atoms. So it is called 3No9. Condensed structure of 3No9 will same. Write carbon and hydrogen together and draw triple bond between 4 and 5. So this becomes 4No9 skeletal structure. Similarly, you draw 9 zigzag lines like this. Add 2 more lines between 4 and 5. So it becomes 4No9. Its uses. Its physical state is also liquid. Okay. It is used in preparing pyrrole derivatives. No9 is used in pyrrole derivatives. This is the skeletal structure of 4No9. No9 is used in preparing pyrrole derivatives. Let us see the next member of this OpenChain Alkynes. The next member is 10 carbon atom alkyne. Since it has 10 carbon atoms, it is called decyne, because 10 carbon atom is, root word is dec, suffix is -ine, so the name is decyne. Molecular formula is C10H18. Let us start with the structure of 1-decyne. The triple bond will be between first and second carbon. So it is 1-decyne. So there are total 10 carbon atoms. It is decyne. Each carbon atom should have 4 bonds. Okay. Now the condensed structure of 1-decyne. We have to write carbon and hydrogen together without a single bond. So this will be CH triple bond C single bond CH2, 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 single bond CH3. This is 1-decyne skeletal structure. You draw a zigzag line up to 10 and draw 2 extra lines between 1 and 2. This becomes 1-decyne. Let's see. So this is 1-decyne. 2 extra lines between 1 and 2. So 1-decyne. 2-decyne structure. The triple bond will be between second and third carbons. So it is called 2-decyne. There are 10 carbon atoms altogether. Okay. And 18 hydrogen atoms altogether. Condensed structure of 2-decyne. So we will start with CH3 and a triple bond between second and third carbon atoms. So this becomes condensed structure of 2-decyne. Now for skeletal structure of 2-decyne, we draw 1, 2, 3, 4, 5 up to 10 zigzag lines and add 2 more lines between 2 and 3. So it becomes 2-decyne. Now let's see 3-decyne structure. The triple bond will be between third and fourth carbon atoms, so it is called 3-decyne. Now the condensed structure of 3-decyne is like this: CH3 single bond CH2, single bond C, triple bond C, single bond CH2, 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 single bond CH3. So there are altogether 10 carbon atoms and 18 hydrogen atoms. This is the structure of 3-decyne. The skeletal structure of 3-decyne will be: draw a zigzag line up to 10 and add 2 more lines between 3 and 4. So this is 3-decyne. Similarly, 4-decyne. 4-decyne, the triple bond will be between 4th and 5th carbon atoms. Condensed structure of 4-decyne is same. CH3 single bond CH2, single bond CH2, single bond C, triple bond C, single bond CH2, single bond CH2, single bond CH2, single bond CH2, single bond CH3. So there are altogether 10 carbon atoms and 18 hydrogen atoms. Now the skeletal structure of 4-decyne. So draw 2 more extra bonds between 4 and 5. So this becomes 4-decyne. First to draw a zigzag line up to 10 and draw a zigzag line up to 10 and then draw 2 more lines between 4 and 5. This becomes 4-decyne. Next is 5-decyne. Here the triple bond will be between 5th carbon and 6th carbon atom. So there are altogether 10 carbon atoms, 18 hydrogen atoms. Each carbon is having 4 bonds. So this is 5-decyne. Condensed structure: CH3 single bond CH2, single bond CH2, single bond CH2, single bond C, triple bond C, single bond CH2, single bond CH2, single bond CH2 and single bond CH3. This is 5-decyne. Let's see the skeletal structure of 5-decyne. So you draw a zigzag line up to 10 and draw 2 extra lines between 5 and 6. So this becomes 5-decyne. Physical state is, it is a colorless liquid. It is used as model substrate in organic synthesis. So it is used as model substrate in organic synthesis. So we have learned about OpenChain Alkynes in this lecture. In the previous lecture we have learned about OpenChain Alkynes and cyclic alkenes. These alkenes and alkynes are unsaturated hydrocarbon compounds. Thank you for watching. Please like, share and subscribe and comment. These lectures are very important foundation for all the students, including GATE, CSIR, NEET aspirants as well as MSc, BSc, 10th, 11th standard, 12th standard students also. Please watch carefully. Write the notes as I have written, then it will be very easy for you to identify these alkynes. Thank you very much.